So we're at another site in Beaufort County, North Carolina that's a little bit non-traditional water management. This particular site is the only one in North Carolina that I know of where we're doing water capture with sub-irrigation at the same site. It's actually part of a nationwide grants process with several universities out of the Midwest that's looking at basically non-traditional means for water capture and reuse. And this is our project here in Eastern North Carolina. I'm working with Dr. Muhammad Yusuf, who is the lead on this project, and we have a graduate student, Hassan Mersouri, who works on this system. Basically, the theory behind this is if we look at weather conditions in North Carolina, we typically get enough rainfall to grow the crops that we're producing. However, it doesn't come always at the appropriate time. In the spring, we typically have to drain water out, and during the summer times, we need water. We're having to irrigate or pump water back in. This particular system is designed to help capture some of the natural available rainfall that runs off from the site in a holding pond, and then later use it when we need it during the growing season, and not supplement it per se with additional water from an outside source. You only use the naturally available water. That gives us a unique aspect to being able to capture this water and reuse it, in that we can also reuse some of the nutrients that are leaving the site in the drainage water. We're not able to do that on our typical irrigation systems. This pond, this reservoir here is about 1.2 acres. We recently added new control structures that allows us to hold an additional 8 acre inches of water to irrigate and capture when we have runoff events. And then we're able to pump that into the field when we need it. Last year in 2019, we ran this site with corn and had one of the driest years in history. Probably the worst corn yield that I can recall harvesting in the area. And that left a large amount of nitrogen, residual nitrogen, available for off-site losses through the drainage system. And we saw that in the data. But what was really nice in the data is that the fact that we used all the water in the pond for irrigation, when we had that initial flush, we captured a huge percentage of that nutrient loss right here in the pond. And we're able to recycle that back into the field where that crop can use it as a later date. And that's one of the nice benefits of this project, is using naturally available water without outside pumping costs from groundwater supplies or somewhere else. And we get profitability by recycling those nutrients. You can see the setup here. This is what houses the pump for the pond. It pumps the water into a holding tank that provides the head needed to get that water into the subsurface irrigation system that's out in the field. And then we have a control apparatus up here in this pump house that basically manages the pump and ensures that we're pumping water when the levels are adequate in the pond and the levels are adequate in the tank, that we have that constant water supply to put the water back in the field. The site that, the system we saw at the open ditch site, automated control drainage, we have a system pretty similar to that here at this site that manages the water table, and will actually send a pulse that turns on the irrigation valve when water is needed, that puts that water back into the tile system out here to our right. And that's done on a real-time basis during the growing season when we need water. So here at this site, we've got soybeans in 2020. This is the second year that we've had soybeans out here on this water reuse site. Previously, we've done a lot of studies with the automated structures on soybean protocols that was sponsored by the North Carolina Soybean Growers Association. And we're continuing to test those protocols here at this site with the water that we have available for irrigation. And you can see on this plot, this is the stress indexes, relative stress indexes that soybeans see during the growing season. At this site in 2020, we actually have a 5.1 indeterminate variety. So we're blooming a little bit earlier than a typical determinate variety, and that's continuing throughout the season. So right now we're currently in irrigation mode. We're at basically R1, blooms are just now setting. So we'll run that irrigation protocol continuously throughout the bloom and pod fill stage for our stress indexes. And you can see from this chart, if we're talking about irrigation and water management, whether it's sub-irrigation or overhead irrigation in the unsaturated zone, this is the critical time to make sure we do a good job of alleviating soybean dry stresses. Now, if we switch gears on that and talk about a drainage standpoint, and we look at the bottom of this plot, you see that from emergence all the way through R6, we can have serious yield losses with soybeans from having too wet conditions. That means that our drainage systems really pay in the blacklands continuously throughout the growing season for soybeans, and we need to do a great job of managing our outlets and our systems to ensure that we don't get extremely wet conditions for a prolonged period of time. That's what our automatic system here is trying to do, is monitoring the water table and making changes to our subsurface drainage system and our irrigation system on a continual basis moving forward.